Okay, so let's look at some examples here. Okay, so let's look at example 1 here. Okay, so we have z equals 10I. Graph each complex number, and then we're going to convert it into polar form. We're going to get it. We basically just have to find r and theta. If we can find r and theta, then we can just. So we're going to see a lot of similarities between what we do here and what we do with real numbers. So z equals 10I. We have to understand that this is really z equals 0 plus 10I. Right? The real number component is 0. The imaginary is 10. We can always graph that order pair. So order pair as 0, 10. This is going to be along the imaginary axis. So we can just plot that point 10. Okay, we want to get it into r cosine theta, I sine theta form. This is polar form. Polar has radius and theta. So we don't have to utilize all this formula here. I think we can just figure out by looking at this here. What's the radius? 10, right? It's along the x-axis, so there's no need to go through Pythagorean theorem. Sorry, it's along the y-axis, so no need to use Pythagorean theorem. And theta, what's the angle measure? I don't think we have to go through tangent, right? What is that theta measure? Right on the pi over 2. Yeah, so theta is pi over 2. So that's all we need. Once you have r and theta, you can just put into your polar form here. Let me zoom in a bit. So there's my radius, there's my theta, and then the shorthand form of writing this is 10 CIS pi over 2. Okay, these mean the same thing, but a lot of times we're going to use shorthand form to rather than writing all these out. Okay, understand what CIS means, just cosine theta plus I sine theta. Okay, any questions? Number 2, let's graph that point. 4 minus 4 root 3, so it's going to be in the 4th quadrant here. Okay, so now this requires us to go to Pythagorean theorem, right? We're not going to know what that distance is or that modulus is just by looking. So we'll go to Pythagorean theorem. R is square root of a squared plus b squared. Now make sure that if you enter this in the calculator that you're putting the parentheses around the 4 root 3 entirely before you square. Okay, if you just do 4 root 3 without the parentheses, and make sure if you put squared that you're putting it outside the parentheses. Okay, not inside, outside the parentheses. Okay, so try plugging that in. What do you get as your radius? Yeah, root 64, which is 8. Okay. We can't look at this and know exactly where that angle is, but we can use the inverse tangent. Y over x. Remember, anytime you're involving theta to find angle measure, you're always going to have to decide which quadrant it's in, and either involve 180 or 360, right? We're always going to have to recognize that we're only starting with the reference angle, and we have to adjust to get the proper angle measure. Oh, sorry. By the way, here this is radian. Okay, so if you want to do it in degree form, that's fine. Do degree form, and then we'll convert to radians after. Okay, but we have to represent our answer in terms of radians because that's what theta is defined to be. Okay, so enter that in the calculator. You should get -60. And then which quadrant is this in? Fourth, so we need to add 360, right? And what's the radian version of 300 degrees? By pi over 3, right? And if you're not sure, you can always multiply by pi over 180 or divide 300 by 180 to get that fractional value. Okay, right now let's practice writing in both forms so we can kind of get that practice, but eventually you can get it just writing that shorthand form. Okay. So right now, I want you to write it in both forms so that you're accustomed to understanding that they are the same things and one is just an abbreviated version of the other. Okay, so now we've converted from rectangular to polar, and now we're going to do the other direction. We're going to go from polar to rectangular. And the way that we're going to do that is we're going to rely on trig. Okay, A is r cosine theta, and B is r sine theta. And we're going to get it into rectangular form. Rectangular form for complex numbers is going to be a plus bi. So we're going to find the a and b value and just put it into that form. Okay. Anybody still need to look at number 2, 1 or 2? Okay, everybody okay? Okay, so number 3. This is written in polar form. Let's identify the parts that we need. We're also going to graph the point as well. What's the 5 referring to? That's the r. And then 120 is the theta. Okay, let's plot the point first. So we're 120, that's in the second quadrant. 5 units towards 120. Now we're going to find the complex or the rectangular form of that point. Okay. So we're going to rely on our formulas here. A is equal to r cosine theta, and B is equal to r sine theta. Sorry, r is 5. I should start inserting that in. Use your calculator or just use your unit circle knowledge. Cosine is going to be negative in the second quadrant. Sine is going to be positive in the second quadrant. So there's my A, there's my B. I'll put it in that form of A plus BI. Okay, try number 4, same idea. Find your radius, find your theta, graph the point, and then convert using r cosine theta and r sine theta. Give you guys a chance to try it first, and then I'll show the answer. Okay, which quadrant is 7 pi over 6? Third, okay. Towards or away? Away. Cosine and sine are both negative in the third quadrant. Okay, that's all we're going to do today. Just converting back and forth between one form to the other. So classwork, page 19, 1 through 4, you're just getting that polar form into complex form. And then 5 through 7, you're going from polar to rectangular. Okay. And I'll work through each problem, and you guys can kind of follow along and see if you're on the right track. Okay, so page 19. Remember, look at the direction though. You can do something in degree form. Just make sure you convert it back to radians because we want theta to be in terms of pi. And if you're comfortable using the short abbreviated version, you can do CIS, okay, RCIS theta. Okay, check your answers 1 through 4. Let me know if you have any questions. Thanks. Everybody good with 1 and 2? Okay, is anybody still working on 3 and 4? That's okay, 3 and 4? Good. Give you guys a chance to finish up, and I'm just going to come around and check 2 pages, page 18 and 19. Okay, so show me page 18 and 19.